All right, ladies and gentlemen, feels like we haven't taught any math in a long time. That's because we haven't. Now, to get a little bit weird on you, this is chapter 2 from the textbook. We skipped this, and I skipped this intentionally to come back to it. But I just wanted to do it in a different order. Arguably, I could have done it 2 units ago, but we're definitely doing it now. Yeah, so just that's where it's coming from in the textbook. 5 lessons, yes. 1 study day, 1 evaluation day. Do you remember that? Do you remember those days where it was an evaluation day, not an evaluation week? When I had to mark for 18 days in a row? That's why I'm teaching math. Anyways, it will be 5 lessons. I think I was looking at the calendar. When we're doing our kind of around 3 or 4 lessons a week, it's just so weird. Not like I need to tell you guys, but it's just so weird because looking at the calendar, and there'd be just, there's different shortened classes for assemblies, for chapels, different things going on, different kids missing for different things. Well, now it feels almost like we've added time, which I suppose isn't a bad problem to have. Depends. But we should be able to finish the last unit with still a fair amount of time. Like, we should be able to be done all this before June, I think, which is kind of the way I want it to go. But I thought we were going to have to cut stuff. Like, I still am on the fence about cutting stuff in physics. Anyways, can you tell I just miss hearing my own voice? All right, so that's the first page. You got it? That's really good. Congratulations. This is the next page. Ignore the red line and the upside down chapter 2. I printed this at home and not at school, and it doesn't matter. It just prints weird. Like, look, why is it all up into the corner like that? Why isn't it centered? Bugs me. Anyways, write that down. Good writing. Absolute value of a real number. The absolute value of a real number tells you how far away a number is from 0 on the number line. The absolute value of a number is really its positive version. Similar to the idea down here, a principal square root is a positive non-negative square root. The example that is given in the textbook is it shows the area of something. If the area of something is 4 and it's a square, what is its side length? Well, you wouldn't say plus or minus 2. You would give the principal square root. So here you go. Let's go to that. Again, look at this whole piece of paper, and it's up in the corner, whatever. So here's the thing. Actually, don't write this down just yet. If you already have, then stop it. Like I said, I'm going to try and give you guys like the questions from the assignment. I'm going to give you CYU 2 and 3. We're going to do 2 to 3. But we are going to do, instead of CYU number 4, we are going to do 12, A, and D. Those are going to be the ones that we do from the assignment. I didn't want to take ones from the assignment here because they are 3-second questions. So I just wanted to be able to teach it without also doing it for you. All right. Cool. You see that? That's good. I'm going to pause it while I reconfigure to get my example papers. Pause. Just a friendly reminder, do read example number 1 on page 85. Do that, okay? You don't have to do check your understanding. I was going to say control your example. Do read example 1, okay? All right, what did I say? We're starting with CYU numero 2 on page 87. So, CYU number 2, page 87. 87, we're moving backwards. I think the question is arguably longer than what the answer is going to be for these ones. So it's got A and B. It says use absolute value to determine the distance between each pair of numbers on a number line. Sketch a number line to illustrate the solution. So I have a number line. And it's a number line, so this is to positive infinity and this is to negative infinity, right? And that's a little bit crooked. You get the idea. It's not crooked if I hold it like this. So 2 numbers. One is negative 3.57. I'll put 0 over here. Negative 3.57. Where did I get that from? Negative 3.7. And then a little further along is negative 8.5. right? So it's like -1, -2, blah, 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 blah. So +1, +2, blah, blah, blah. What it wants to know is the difference between these two. Okay? That's it. That's all there is to it. Like, I don't want to go too fast in case it's just obvious to me and not to anybody else. A couple ways you could do this. One, if you just kind of ignore the negatives, just get that space between, right? If this was 8.7, it'd be a distance of 5, right? But instead, it's going to be 4.8. Do you see how I'm doing that? Like, another way of doing it is just saying, again, ignore the signs, 8.5 minus 3.7. That is the distance between these two. There is no negative distance. You know, if I walk to the school backwards, it doesn't make the distance negative. It's always going to be positive. And that's the way the absolute value works. Okay, that's it. Please make a comment, say something if I'm rushing through this, if I'm missing something that's obvious. Next one, 4 2/3 and -5 3/5. Well, it's getting way fancier, hey? Number line, I'm going to put 0 in the middle this time. Over here we have 4 2/3, so it's going to be somewhere over here, 4 2/3. And then on the left, -5 3/5. -5 3/5. One of the ways to consider this is look at the distance. I'll use that color. Cat hair in my mouth. Gross. Look at that distance. Look at that distance. This distance is 5 3/5. This distance is 4 2/3. They're both positive. You just need to add those together. And then you will have the distance between them, right? 5 3/5 plus 4 2/3. Common denominator. Gross, I can hair in my mouth. I'm going to change these to improper fractions. 5 times 5 is 25. 25 plus 3 is 28. 28 over 5. 3 times 4 is 12. 12 plus 2 is 14. Plus 14 over 3. You need a common denominator before you can add these bad boys, right? Common denominator is going to be 15. So we're going to multiply this by 3 over 3. Plus 14 over 3 times 5 over 5. I feel like I'm writing too small. Am I writing too small? I'll write a little bit bigger. 3 times 28 is 75 and 9, so that's 84. So that's 84 over 5. Nope, over 15. 5 times 14 is 50 is 70. 70 over 15. This is going to be 154 over 15. As if 3 and 5 don't go into 154. Is that it? Is that the final answer? Yeah, it's 154 over 15. You can also you could also simplify this. I don't like mixed fractions. I'm not a fan of these things. What the heck? It's like I ate a cat or something. I don't like these. I prefer this fraction, but if you want, 15 will go into this 10 times, right? 15 times 10 is 150. 4 is your remainder. Anyway, that's check your understanding. Numero dos. Let's do numero trois. Numero. CYU 3. Where is it? It is on page 88. Oh yeah. I wanted to do this one because I don't even know if you get a question like this exactly. Yeah, not even really. So that's why we're going to do this one. And really, I think it's really straightforward. But it's set up in a way to, I guess, to make you think, to make you understand, to help you to try and just really get a good comfort level with, oops, cubed, hello, with absolute values. When you see something in absolute values, like if I say like 1 minus 4 in absolute value, and it's tricky, right? Because these look like ones. Try and make them a little bit bigger than everything else. You can treat them a little bit like brackets. 1 minus 4, that's going to be negative 3. Okay. But then the absolute value of negative 3 is 3. Whatever's inside of these absolute value markers, though, you treat it like a bracket. You do what's in there before you do anything else. If we had a 2 in front of this, then you simplify everything in here, and then it'll be 2 times 3. Won't be 2 times negative 3 or anything like that. Wait till you do what's inside, and so on and so forth. So with this, I kind of think the reason they set up the question like this is they want you to see that like this squared, that counteracts the root, right? So it's kind of like, well then, what if I just cancel those? Cancel the root, cancel the square. Final answer will be negative 3. But not with absolute values. If we actually do what's in the brackets first, which is what we're supposed to do with BEDMAS, 7 minus 10 is negative 3. Then the exponents. You work outwards. So that's going to kill the negative, right? Now this is our principal square root. This is our principal square root. You could say plus or minus, but when we're talking about absolute values, we're going to keep it positive. What did I say I was going to do? I was going to do 2 questions here. Should I use the same page? Let's try it. 12a. Where? Oh, yes. Yes. 12a. So this is page 92. Numero. I have no idea how to say 12 in any language. So make these things bigger. 5 times 4 minus 3. See, if I just do like this, it'll look like 31, okay? I'm exaggerating. It doesn't have to be that big, but it's totally fine. So you do what's your regular order of operations. Everything is wrapped inside of these 2 bad boys, so we are just going to leave them alone until we have one number in here. 5 times 4 is 20. I'm just doing this one step at a time. 20 minus 3 equals 17. Well, guess what the absolute value of 17 is? 17. Cool, cool, cool. So that's what I'm saying. You kind of treat it a little bit like brackets. Let's do just a little bit of a harder one for 12D. Absolute value of 6 plus negative 10. So, and they come in pairs, hey? Like if you have another one out here, something's wrong. They come in pairs, same as regular kind of brackets or parentheses, if you will. So you know that this is a kind of a pair, and I'm saying that because next we have a negative sign, it's just floating there by itself without any friends. And then we have 5 minus 7 over here. This isn't a separate set, like in between here, okay? It's not, oh, that instantly turns into positive. It doesn't. This is a set, and it's just this set minus this set, okay? I'll come back to this in a second to tell you something else. Let's just do these. So 6 plus negative 10 is going to be negative 4. Absolute value of negative 4 minus 5 minus 7 is negative 2. Cool? Equals an absolute value of negative 4 is 4. That negative just stays. Absolute value of negative 2 is positive 2. So all this mess here, whoopsies, all this here equals 2. Now what I wanted to say is this negative is a little bit like negative 1. It's a lot like negative 1. It's like negative 1 is going to multiply whatever's inside here. This became positive 2. So if this multiplied it, it'd be 4 plus negative 1 times 2. 4 plus negative 2. Same idea. The reason I say that, some of you might be like, what the? Is because you're going to get more questions, but like see for F, we just did D. For F, it's got a 2 on the outside. It's not negative, but that 2, oh, look at that. Yeah, I guess there's going to be more there. Good. Like brackets. So that negative 3 waits till everything's settled in there. 4 minus 1 is going to be 3. Negative 3 times 3. Okay, and then 2 times the result of that, etc., etc. So they are like brackets in that sense. Okay, that's enough talking for me. Your assignment, shall you choose to accept it? Because really, at the end of the day, you have a choice, is right here. I think it's straightforward. I think it shouldn't take you too long. But there's probably going to be questions because, you're learning. You haven't done this before. I have. Let me know if you got the questions.